Hello and welcome to today's session. We are going to be looking at trigonometry. Under trigonometry, we shall be introduced to different trigonometric ratios. And these ratios include sine, cos. We are going to look at the sine, the cosine, and then the tangent. We call this sine, this is cos. This will be tan or the tangent. Now, these are the three different ratios we are going to look at this time. And these ratios are very simple to understand. We are going to look at them under trigonometry, but with an easy way to understand them. I will recall a simple assessment or a simple formula we used to have when I was a student. And it was going as so. Toa. In SOHCAHTOA, it was always easy for us to understand that sine of an angle theta is given as opposite out of the hypotenuse. Cos of an angle theta is given as the adjacent out of the hypotenuse. And then tan of an angle theta is given as the opposite out of the adjacent. This was a simple way of understanding the three formulas that we were supposed to use. But then furthermore, we need to understand what are these sides called, what are these? And this takes us to a simple right-angled triangle. And in this simple right-angled triangle, let us assume that this is our angle theta. And that being our angle theta, we look at the different points. Now, there is a line here, the side. This side will always make an angle of 90 degrees, but this side is opposite to my angle. This side and the angle are opposite, so I can call this side the opposite. Now, I come to these two remaining sides that meet to form our angle. And when we look at these two lines, the shorter line, we shall call it the adjacent. And the longer one will be called the hypotenuse. And the longer one will be called the hypotenuse. That takes us to a simple way of understanding. Recalling that we used to have Pythagoras theorem. If this is our angle theta, this side was called A, B, and this can be C. We can recall from our primary session under Pythagoras theorem that side A squared plus side B squared must give us side C squared. This identity will be crucial in our next assessment. So we can now continue having these as the different sides and understanding trigonometry. We can come to the trigonometric ratios. These will be sine, cosine, and tangent. Understanding that they can come out of our simple left formula, which can be analyzed as SOHCAHTOA. And in SOHCAHTOA, we can see that the sine of an angle theta is given as opposite out of the hypotenuse. And then we can see that our cosine, which is cos of an angle theta, will be given as the adjacent divided by the hypotenuse, and the tangent of the angle theta will be given as the opposite divided by the adjacent. Furthermore, we continue and say these sides that we've been introduced to, the adjacent, the cosines, the so and many other forms, we can look at this as our right angle triangle, having different sides. But we say if this is our angle, the side opposite the angle is called the opposite. That side is called the opposite. And then the side where the angle sits, the shorter side, is called the adjacent, and the longer one in length is what we call the hypotenuse. Furthermore, we also need to recall that from our primary session when we have the right angle triangle, it was always easy for us to say that a squared plus b squared is equivalent to c squared, being a general formula from Pythagoras that can help us to find the missing sides of a triangle. So we can continue and analyze, understanding trigonometry in its normal way. Like we said in mathematics, We can have a grid, for instance, of that kind. But what if this grid in this form is going to divide a very big circle, which talks about angles, which keep on moving in evolution. Angles keep on moving and they keep on increasing. Assuming this is our 0 degree, and this will be 90 degrees. Adding on another 90, this gives 180 degrees. Adding on 90 degrees, this gives 270 degrees. And adding on another 90, it gives 360 degrees. To the understanding of this being 0, 90, 180, 270, and 360, this gives us an understanding. These are different quadrants divided. This can be our first, this is my second, this is the third, and this is our fourth quadrant. But still, in all of these quadrants, angles do feature there from 0 to 90, from 90 to 180, from 180 to 270, from 270 to 360. Yes, they do feature, but we need to understand if they feature, what happens to them? What happens if they do feature? We need to understand. So, angles where they do feature, also trigonometric ratios must come in existence. For instance, this will be sine, cos, and then tan for our level. So we need to understand the behavior of these three in these different quadrants. So for instance, in the first quadrant, we shall come to our notice that all ratios, all trigonometric ratios are positive. What do I mean by this statement? Saying that all trigonometric ratios are positive. This happens in the first quadrant. By this I mean, in the first quadrant, the value of sine is positive, the value of cos is positive, and the value of tan is also positive. When I say the value of tan is positive, I mean if an angle is picked from 0 to 90, all angles picked between 0 and 90 degrees, their sine, the cosine, and the tangent are all positive. For example, you can place your calculator at your free time and say, the sine 60 degrees. I'm sure it must give you a positive value. You press a value like cos 60 degrees, it must also give you a positive value. A value like tan 60 degrees, it will also give you a positive value. So that happens in the first quadrant. Then when we go to the second quadrant, in the second quadrant, what happens is very simple. I used to have an assessment when I was young, and I used to say all student teachers came. It was very simple for me. But still, I don't want us to look at that right now. But what happens in the second quadrant is very simple. Here we've seen that all are positive, not so? All are positive. So in the second quadrant, the sign is positive. Our sign is positive. Cosine, the cosine is negative, and the tangent is also negative. I've said in our second quadrant, the sine is positive, cosine is negative, and the tangent is negative. What does this mean? In angles from 90 to 180, if we pick an angle there and we place it on a curve, for example, if we place sine 120 degrees, it will give us a positive value. But if you place cos 120 degrees, you're going to get a negative value. And when you place tan 120 degrees, still you're going to get a negative value. So we continue, and we need now to understand what happens in the third quadrant very fast. In the third quadrant, it is always very simple to know. In the third quadrant, the tangent is going to be positive. And when the tan is positive, sine will be negative. The value of sine is negative. And the value of cos is also negative. I've said in the third quadrant, tan is positive, sine is negative, and the cosine is also negative. Furthermore, we can now look at the fourth quadrant as our last quadrant, and we shall see that in the fourth, what happens is very simple. This time cos is positive, which means sine is negative, and tan is also negative. So this means that if you pick an angle from 270 to 360 degrees and you place it on the calc, for instance, cos 300 degrees, it must give you a positive value. You place sine 300 degrees, it will give you a negative value. You press tan 300 degrees, it will also give you a negative value. So the understanding is very simple, that in the first quadrant, all of the ratios are positive. In the second quadrant, only sine is positive. And in the third quadrant, the tangent is positive. In the fourth quadrant, the cosine is positive. So we come up with a simple assessment of knowing all science teachers came, and it was always easy to understand the behavior of different ratios in the different quadrants.